Hello, fellow chemists. In this video, we're going to be taking a look at converting between grams, moles, and atoms. This is labeled as an advanced video because it assumes you understand the mole, Avogadro's number, molar mass, calculations with molar mass, formula mass, and molecular mass. If you need a review of those topics, I'll put a link in the upper right-hand corner. All right, so in this video, we're going to be doing just two problems, but they're going to be two problems that are a little bit more advanced. And I do have our little guide up here, and if you don't already know it, I strongly recommend that you learn this guide. It shows you very succinctly how to go back and forth between atoms, molecules, moles, and grams. It lets you know when you're supposed to multiply or divide by atomic mass, and when you're supposed to multiply or divide by Avogadro's number. And as we go through the problems and use the factor label method, we'll look up here and make sure that everything that we do with the factor label method is matching up with what this little guide table up here says. So let's get started with the first problem. The first one says, if you have 17 grams of C2H6, how many C2H6 molecules do you have? So we're going to start at grams, then go to moles, and then go from moles to molecules. So we can see this is going to be a multi-step problem. So we want to end up with C2H6 molecules. And one thing that you want to be careful of, a lot of my students have trouble with this. Whenever there's a problem that involves molecules and moles, a lot of times the students will abbreviate both of them as MOL. That causes a lot of potential problems because they mix up the units then. Moles and molecules are two different things. So be very careful that you're not abbreviating them as both MOLs and then starting to lose track of what you're working with. All right, so with this one, we are working with a molecule. It's C2H6, that is ethane, and we are going to need to learn its formula mass, so we might as well do that first. So C2H6, we have carbons, and each carbon weighs 12.01, and we have 2 carbons. So that means the carbons are going to be donating 24.02 to the overall formula or molecular mass. Then we also have hydrogens, and they weigh 1.01, and we have 6 hydrogens, so that comes out to 6.06. So if we add both of those up, we get 30.08 as and that's in grams per mole, as the molecular mass or the formula mass for C2H6. And we're going to be using that formula mass in the first step to go from grams to moles. So we have 17 grams, so we'll start with 17 grams of C2H6, and now we're going to use our formula mass to convert from grams to moles. We'll put grams on the bottom so they cancel out, and moles on the top. We have 30.08 grams for every 1 mole. Grams and grams cancel out, and what we're going to be doing here then is dividing the 17 grams by the atomic mass. And look, as it says, to go to moles, you take the grams and you divide it by the atomic mass. So that does hold true. So if we take 17 times 1 and then divide it by 30.08, we get 0.565 moles. Now we're going to need to go from moles to molecules, and to do that we're going to multiply by Avogadro's number. Now we need to be careful, we're working with moles and molecules here, so we don't want to mix up our units. So we have moles, we're going to put moles on the bottom so they cancel out, and then molecules. Squeeze it in up there so we don't mistake the two terms. So for every 1 mole you have 6.022 times 10 to the 23rd molecules. Moles and moles cancel out. And you can see we're going to multiply moles by Avogadro's number to get the molecules, so that is exactly what the formula up there says. And if we take 0.565 and multiply it by Avogadro's number, we get 3.4 times 10 to the 23 molecules. molecules of C2H6, and that's what we're being asked to solve for, so that will be our final answer for the first one. So there we had really three steps. The first step was you had to find the formula mass. The second step was converting from grams to moles, and then the third step was converting from moles to molecules. Now, the second one is going to be even a little bit more challenging. This one actually has 4 steps. And this one, I actually bring a liquid drug in, and you have to use the density. So we're actually going to be working with volumes here as well. So it just adds a little bit more complexity, another level of understanding that we have to deal with to answer the problem. So let's read the problem first. It says, if you have 4.37 times 10 to the 23 molecules, okay, so we're starting with molecules, and it's of methanol, CH3OH. How many milliliters of methanol would you have? And then I give you the density. Well, we can go from molecules to moles, and then we can go from moles to grams, and then we can use the density to convert from grams to milliliters, and it's asking us for milliliters. So quite a few steps, but we can figure them all out here. So we're going to find milliliters, and this is going to be milliliters of methanol, CH3OH. So if we just kind of draw a little diagram up here of what we're going to be doing, we're going to go from molecules, and then we're going to go from molecules to moles, and that's going to be using Avogadro's number. And then once we're at moles, then we're going to use the molecular mass, which we have to find, or formula mass, same thing, to convert into grams. And then once we get into grams, we're going to use the density which we're given to convert into milliliters. So these are the steps that we're going to go through. A lot of times when doing these kinds of problems, students just start writing stuff down, but they don't actually figure out the steps that they need to follow. So mapping out what you're going to do to solve the problem really helps. So now that we kind of know what we're going to do, let's just start by going from molecules to moles. So we have 4.37 times 10 to the 23 molecules. And we're going to need to use Avogadro's number to convert to moles. Molecules on the bottom, moles on the top. See how it is easy to mix up those two terms? That's why you got to write them out. For every 1 mole, you're going to have 6.022 times 10 to the 23rd molecules. We have it set up so that molecules and molecules will cancel out. And if we take 4.37 times 10 to the 23rd and divide it by 6.022 times 10 to the 23rd, we will get 0.726 and moles. So now we are in moles. Next step is going to be to go from moles to grams. And to do that, we're going to need the formula mass of our methanol. So now we're in moles. I'll just put a little underline there to let you know that's where we're at. But we need to now find out the formula mass of methanol. So we have a carbon, and that carbon is 12.01. And there's only one carbon in here, so 12.01 is what that carbon is going to contribute to the formula mass. We have some hydrogens. They weigh 1.01, and we have 4 of them. That's going to be 4.04. That contributes to the overall mass. And then we have 1 oxygen, and that's going to be 16. It's actually 15.999, but I'm going to round it to 16. Multiplied by 1 gives us 16 for the contribution of oxygen. If we add 12.01 plus 4.04 and 16, we get 32.05 grams per mole. And that is the formula mass for methane. And we're going to need to use that in the next step. So now we're going to take our 0.726 moles, and we're going to convert it into grams using the formula mass. So we'll put moles on the bottom, grams on the top, and we have 32.05 grams for every 1 mole. Moles and moles cancels out. If you take 0.726 times 32.05 and divide it by 1, you get 23.27 grams. And that's 23.27 grams of our methanol. But that's not what the problem wants. It wants milliliters. So we're right here at this point. So we need to use the density to get to milliliters. So we're almost there. We only got one more step. So now we're going to use the density as a conversion factor to convert from grams to milliliters. So grams on the bottom, milliliters on the top. And it's 0.792 grams per milliliter per 1 milliliter. Grams and grams cancels out. So if we take our 23.27 times 1 divided by 0.792, that'll give us 29.38 and milliliters of methanol. And that, my friends, is how you solve that problem. So you can see hopefully why this was labeled as an advanced video, because these problems, these would be on an exam. Like I said, professors usually give you a small percentage of the questions that are easy, that are about 1 step. The majority of the questions are medium level, that are 2 or 3 steps. And then they always put a couple of the hard questions on there that are 4 or more steps, kind of like this one. And that really separates out the A students from the B students. All right, I'm glad you made it to the end of this one. It was a tough one. That's the end of this lesson. I sure hope you learned something. If you did, leave a like and subscribe, and I will see you in the next video.